Okay, so now on to numbers 8, 9, and 10. So number 8, the length of a rectangle is 3.2 feet more than 7 times its width. So we have the length of a rectangle is 3.2 feet more than 7 times its width. The area of the rectangle is 91.8 square feet. Well, if the area is length times width, and the area here is 91.8 feet, then if my length is 7w plus 3.2 and I multiply that times the width, so here's my length times the width, that will be equal to 91.8. So if I distribute this w, I'll get 7w plus 3.2w. And then if I subtract the 91.8 over, I got this quadratic set equal to 0. So now I could use my quadratic formula to solve for the width, because if I know the width, then I know the length because I have a formula for the length. So let's give myself a little more room here. So here I have w equals, so negative b, so negative 3.2 plus or minus the square root of b squared, which is 3.2 squared, minus 4 times a, which is 7, times c, which is negative 91.8. All of that divided by 2 times a, which is 7. So this right here, the discriminant, that's equal, so here we'll have the square root of, so 3.2 squared minus 4 times 7 times 91.8 is 2580.64. So whenever I take the square root of that, I'll have w equals negative 3.2 plus or minus. So the square root of 2580.64 is 50.8 all over 14. So then here you'll get one of two things. So if I have negative 3.2 plus 50.8 divided by 14, I'll get 3.4. If I do negative 3.2 minus 50.8 divided by 14, I'll get negative 3.84 something. But my width, since this is a rectangle, cannot be negative, so my width is 3.4. Now because I know that my width is 3.4, I can plug that back in for w, for the formula for the length, and I'll get my length equal to 27. So the dimensions are a length of 27 feet and 3.4 feet for the width. Number 9, a rectangle has a perimeter of 55 feet and an area of 187.24 square feet. Find the dimensions of the rectangle. So I'm just going to draw a picture over here. Rectangle. It has a perimeter of 55 feet. And an area, so opposite sides on rectangles are, I'm just tongue-tied today, rectangles are equal, so if those are both x, we could call these both y. Okay, my area is 187.24. So if perimeter is x plus y plus y, in other words, 2x plus 2y equals 55, and area is length times width, so x times y equals 187.24. So if I want to use these, we could do substitution. I think what I'm going to do is solve both of them for y so that I can set them equal to each other. So for this first one, I'll subtract 2x from both sides, and then divide by 2, and I'll get y equals sorry, that should not be there. Y equals negative x plus 55 over 2. Okay, so I've got that y equals. The second one, if I divide both sides by x, then I'll get y equals 187.24 over x. So I've got this is equal to y, this is equal to y. So then I could set these two things equal to each other. So I'll have 187.24 over x equals negative x plus 55 over 2. So if I rearrange this a little bit and work with it so that way I can have everything on one side of the equal sign. In other words, first I'll multiply everything by x to get rid of this x in the denominator. And then I'll subtract the 187.24 over. And I'll end up with x squared, negative x squared, plus 55 over 2 times x minus 187.24. So now I'm going to plug into the quadratic formula. I'll use an a value of 1, negative 1. B is 55 over 2. And C is negative 187.24. So I'll plug that into negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I will get an x value of 12.4. So x will equal 12.4. And since we know x, because of this right here, to find y, we just plug in x of 12.4 there. And 187.24 divided by 12.4 will give us a y value of 15.1. So those are the dimensions, 15.1 by 12.4. And then finally we have number 10. So we have an object was projected upward with the following data, times t from when the object was projected, 2, 4, and 5 seconds, with the respective heights h, 205.4, 346.6, and 402.4 meters. So it wants us to find the quadratic function of height h in terms of time t. So let's make a table. So we have t and h. So we had 2, 4, and 5 seconds. And at 2 seconds it was at 205.4. At 4 seconds it was 346.6. And at 5 seconds it was at 402.4. So to find this quadratic function, let's go back to the calculator like we did before. So if we go to the home screen and make a new document, say no to save, let's start out by adding lists and spreadsheets. Call the columns x and y. So we had the x values 2, 4, and 5, and the y values were 205.4, 346.6, and 402.4. So to get the equation, we can go to Menu, Statistics, Stat Calculations, and Quadratic Regression again. So here we'll choose X for the X list and Y for the Y list. Hit enter. And so for ax squared plus bx plus c, it's told us that A is negative 4.9333, B is 100.2, and C is about 24.73. So let's go back over to the other page and write that down. So our regression, or our quadratic function of h in terms of time t is negative 4.93 t squared plus 100.2 t plus 24.73. So there is our function, and it wants to know when did it hit the ground. In other words, when was this equal to 0? So if we set this thing equal to 0, then we can find out whenever it hit the ground, because if the height of the object is now at ground level, that's whenever the height is 0. So we've set our function for height at a given time set equal to 0. Now we can use the quadratic formula just like we did before. So we'll get negative b. So if we want to figure out at what time, we'll take negative b, negative 100.2 plus or minus the square root of b, which is 100.2 squared, minus 4 times a, which is negative 4.93, times c, which is 24.73, all over 2 times a, which is negative 4.93. Then you'll end up with a time value of 20.6 seconds. Okay, well that's it. Hope that made sense and you were able to take good notes, and I'll see you in class. Bye.